So welcome everybody. I'm just going to give you a brief background on Nanion technologies and one of our core technologies, which is automated patch clamp, as this is the subject of the thread tying both of these talks together. This is an exciting time for Nanion technologies. We are celebrating the 20th anniversary of the introduction of our first product, the PortaPatch. And our founders, the PortaPatch is based on technology that came out of work that was done by Dr. Niels Fertig, one of our founders. And then he was joined by Chief Scientific Officer Andrea Brueggemann and our Chief Technology Officer Michael George, as the three main founders of the company. And they've stuck with it for a long time, and they are continuing to participate and drive forward the innovation at Nanion Technologies. So as I mentioned, our PortaPatch has been billed as the smallest patch clamp rig in the world. It was the first product. It's capable of automating the patch clamp of wholesale patch clamp in a one cell at a time format. Over the years, they've introduced further iterations of this technology. For instance, the patch liner in 2006, which can do up to 8 cells at a time, and the synchro patch in 2013, which can bring us up to 384 channel scale. Over this time, as we've gone from automated patch clamp at 1 cell to 8 cell to 384, Nanion has also introduced innovations in other areas of membrane research, including tools for transporter research and for cell monitoring. And there really are three broad categories of technologies that Nanion offers. One being the automated patch clamp, which we'll talk more about in a minute. Another being cell analytics, using impedance measurements, cellular field potential recordings, and actual contractility measurements using the FlexSite 96. And coming soon is Atlas platform, which will use an advanced version of impedance measurements, a spectral, where you can use the entire spectrum of impedance to measure a diverse set of cellular analytics. And finally, a membrane biophysics. We have orbit systems for doing planar patch work for single channel analysis, as well as a Surfer line of products for doing solid supported membrane for doing electrogenic transporter research. But getting back to the technology that started it all is automated patch clamp. The innovation here was to take something that is a very labor-intensive, technology-intensive, space-intensive approach, which is manual patch clamp. And it's based on pipette that is the electrode. And this pipette must be positioned to approach the cell, form a tight seal, and initiate recordings. This requires a vibration isolation table, a microscope, a whole series of electronic amplifiers and digital interfaces, and a skilled operator. And it takes up a large footprint. In contrast, the innovation with the PortaPatch is to make a situation where there's a planar aperture instead of a pipette-based aperture. And in this case, the cell approaches the aperture. This allows you to automate the entire process. It also allows you to miniaturize the entire process. So here's a picture of your patch clamp apparatus in between your laptop and your monitor. It's really that scale of miniaturization. The second thing that going to a planar patch is that you can create an array of sites. And so it's pretty easy to see how this could be incorporated into a 384 format. And that's where we make the leap to high throughput on the synchro patch. So the synchro patch itself is based on a recording chip that has 384 wells. Each well has a micron-sized aperture. You could actually have versions with 1, 4, or 8 apertures, so you could measure an ensemble of 8 recordings from 8 cells. It is incorporated into what we call the patch clamp module, which houses all the electrodes necessary for initiating patch clamp measurements. And in turn, this is integrated into Beckman's Biomech I-Series liquid handler to give you a fully functional machine for doing, screening work. And I'll talk a little bit more about how adaptable it is. But it has 384 individual patch clamp amplifiers with current clamp capability. The i5 liquid handler is a really advanced liquid handler that allows us to do a lot of different things, including ligand-gated ion channel work. The new Synchro Patch has integrated temperature control. The chip itself, it maintains the gold standard borosilicate glass patch substrate. And one really exciting feature of the Synchro Patch is that you can't do in manual patch is we can perfuse the internal solution. So you can actually exchange the entire internal solution while you're recording, just something with a pipette is not really possible. And with this system, you can achieve throughput rates of up to 20,000 data points per day if you're going after a high throughput screening campaign. The Synchro Patch, however, can be quite adaptable. It can do anything from very basic research all the way up to drug screening. And that's in part because we've introduced a 32 well mode where you don't need to waste an entire chip on an experiment. If you're doing real basic research or you're doing assay development, you can do that on a scale of 32 wells at a time for each experiment. And that really makes it very adaptable. So drug screening is an obvious application, but it runs the whole gamut. It's super flexible. You can do anything from basic research, safety, assay development, target validation. The whole gamut can be achieved with the Synchro Patch. And I think we're going to hear quite a bit about that in the next couple of talks as we hear about the Synchro Patch in academic research. But before I get to the introductions, I want to highlight something that's just being announced now, is that we are once again doing a Synchro Patch grant initiative. And this is a really exciting initiative for us. We've done it in the past. It's been very successful. What the basis of this is researchers who are interested in obtaining a high throughput patch clamp system can do so by writing a research proposal, and these proposals will then be reviewed, and we will award the use of a Synchro Patch to the winner of the grant. This is a 9-month free of charge use of the Synchro Patch. We'll install, I'll come out and do the training with you. We provide all the consumables in terms of the chips and the reagents that you need to get started, and you can use this for 9 months. Elena was one of the winners of the Synchro Patch grant in a previous year, and it worked out tremendously well. They were able to get a lot of really nice data to support an S10 grant, with which they were successful in obtaining their own Synchro Patch at the University of Texas in Houston. So I'd like to now introduce our first speaker. This is Dr. Elena Govarinova, who is a research associate professor in the laboratory of John Spudich at the University of Texas Health Science Center at Houston. And the title of her talk is Using the Synchro Patch 384 to Characterize Light-Gated Ion Channels. And with that, I will stop sharing and we can get started.